Okay, today we are going to start our introduction into kinematics. Basically, kinematics is a description of the motion of physical objects. When we start describing the motion of physical objects, we have to look at their position. Position is the placement of a particle with respect to the origin. This is defined as the vector from the origin to the point of location. So let's start by looking at this in one dimension. So by looking at it in one dimension, if we have a number line, and on that number line we have an origin location, and we say our particle is over here, then the distance from the origin to that position gives us our distance, but the vector that goes from the origin to that location is our position vector. Now, if we look at position, we also have to look at distance. Distance is defined as how far a particle has traveled. This is not directionally dependent. So that means that if we travel from the parking lot to Walmart and back to the parking lot, then we have gone twice the distance from here to Walmart. Now this is different if we look at displacement. Displacement is defined as the change in the position of a particle. Displacement is vector dependent, so by traveling from here to Walmart and back again, assuming we have the same parking space, our displacement would be 0. We would be back at our starting point. Okay, so let's start by looking at this in one dimension. If we imagine that we're traveling along just an ordinary number line, let's say the x-axis, and we start out at 5 meters and we end at 12 meters, then in order to find out how much our displacement is, what we're going to do is we're going to take 12, which is our final position, minus 5, which was our initial position, and get that our displacement is 7 meters along that axis. Now in reality, one dimension isn't really all that different from 3 dimensions. The big difference with 3 dimensions is that we now have to look at not only just the travel in the x direction, we also have to look at the y direction and the z direction at the same time. So let's look at an example. So in our example, we are going to start at negative 3i hat, positive 2j hat, positive 5k hat, and our final position is going to be 9i hat plus 2j hat plus 8k hat. And these are all measured in meters. So our displacement is going to be the change between these two vectors. So we're going to have 9 minus a negative 3 in the I hat direction, 2 minus 2 in the j hat direction, and 8 minus 5 in the k hat direction. So from this, we're going to get 12 I hat plus 3 k hat, and our units, of course, are going to be meters. So that's going to be our displacement. Okay, so this concludes our algebraic vector description of displacement. Make sure that you read your text. Make sure you're reading chapters 2 and 4. And when you come to class, bring your questions with you.